Hey guys, welcome to part 5 of the SHSAT math review for 2022. So we're on question 82, and we want to know which of the following numbers has factors that include the smallest factor of 91. Okay. So basically what we want to know, first we need to know the smallest factor of 91. So let's actually factor 91 first. So 91 is going to be 7 times 13. So 7 would be the smallest factor. So therefore, let's read the question again. Which of the following numbers has factors that include the smallest factor of 91? Well, that's include 7. Right? So, which of the following numbers has factors that include 7? Well, 30 is not divisible by 7, right? 30 divided by 7, that is not a integer, right? So, therefore, 7 is not a factor of 30. And similarly, 7 does not divide 39 or 44. It's not a factor. But 35 divided by 7 is 5. So 7 is a factor of 35. So it would be F. Okay. 83. In a scale drawing of a triangular banner. So we have a triangular banner. One side measures 16 centimeters. And the two other sides each measure 12. Okay. On the actual banner, these two sides each measure 36 feet. What is the length of the remaining side? Okay, so this is again a proportions question. So we know that 12 centimeters here is proportional to 36 feet here. And so therefore 16 centimeters, this bottom side, must be proportional to this question mark side. And now we can solve for the question mark by cross multiplying. And we would get 48 feet. So that would be the length of the remaining side. Okay, so now 84. So we have a math quiz and we have scores. So it looks like 4 students scored 85, 4 scored 75, 2 scored 65. We want to know what the mean score is of the 10 students in the table above. So we're not looking for the median, right? We're not looking for the middle score because that would just be like 75. But we're looking for the mean. So the mean is going to be the sum of scores over the number of students. So we know that the number of students, we know that this is just 10. So let's look at the sum. So the sum is going to be here. So let me erase this now. Right, so we know that it's the sum of the scores over 10 students. So the sum of the scores is going to be, well, 4 students scored 85, so we have to add 85 to the sum 4 times. And then 4 students scored 75, so we have to add 75 4 times. And then 2 students scored 65, So we have to multiply that by 2. So now let's actually do this. Okay, so 85 times 4, that's 340. 75 times 4 is 300. 65 times 2 is 130. So the sum is going to be 770 over 10, and that's going to be 77. So that would be G. Now if you wanted to do this by like process of elimination, well, 22.5, that's going to be too low, right? Because everybody scored above that, so that wouldn't be the mean. 85 is going to be too high because only 4 students scored that. Everybody else scored lower, so the mean is going to be lower than 85. And then 75 is not right because fewer students actually, like, okay, so 4 students scored 75, but then more students scored 85 than 65. So the mean is actually going to be slightly higher than 75 because more students scored 85 than 65. So it wouldn't be 75. And so it's going to be slightly higher than 75. So it's going to be 77. So that's another way of doing it. But if you want to check, it's good practice to do the math and like do it out. Okay. So now we're on to 85. So the least of 5 consecutive integers is L. The greatest is G. And we want to know what the value is of L plus G over 2 in terms of L. So the key word here is like in terms of L. So that means we need to express G in terms of L somehow. Right? Because if we can express G in terms of L, then we can substitute G for L and get something in terms of L. Okay, so we know that, so if L is our least consecutive integer, then we have L plus 1, L plus 2, L plus 3, L plus 4, right? So these are our 5 consecutive integers, right? First, second, third, fourth, fifth. And so our smallest is L, and then we're told that the greatest is G. So L over 4 is actually G. And so now we know that G is going to be L plus 4. So we've expressed G in terms of L. And now L plus G over 2 is going to be L plus 4 in terms of G. And then over 2. So this is 2L plus 4 over 2, which in turn is going to be L plus 2. Right, we divide 2L by 2 and 4 by 2 and add them. So this would be C. Okay, yeah, I think that's right. Okay, so now 86. So a car is traveling 55 miles per hour, and 1 mile is 5,280 feet. So we want to know which of the following calculations would give the car's speed in feet per second. Okay. Alright. So let's start with 55 miles per hour. Now we want it in feet per second. So let me go from miles per hour to feet per hour. So we're gonna need miles in the denominator and feet in the numerator, so that miles and feet cancel out. So we know that 5,280 feet is equal to 1 mile, right? So we have our feet to mile. And now we have feet per hour, right? Feet per hour. So we want it in feet per second. So we're going to need to multiply by, right? So we have hour in the denominator here. So we need hour in the numerator here. And we need second in the denominator to get that feet per second. right? Because so then these hours would cancel out. So anyway, we know that for every 1 hour, there's going to be 3,600 seconds, right? You can check that. And so now we can just multiply our stuff, right? So it would be 55 times 5280, and then since this is in the denominator, it would be divided by 3600, and this would be in feet per second. So that, now let's look at our answer choices. So this looks correct, F, right? So yeah, so you just have to do that unit conversion and then see which one of the answer choices works. I guess another way to think about it is that if we're going from miles per hour, let's say like we're going from miles per hour to feet per hour, we know that there are more feet than miles, right? So there's going to be a lot of feet per mile. And so we want to take that 55 miles per hour and multiply it by 5280, because that's going to get us like a larger number. So that makes sense, right? Miles per hour versus feet per hour. Feet per hour is going to be much greater than miles per hour. And then if we want to go from feet per hour to feet per second, well, you're going to go a lot further in an hour than you are in a second. So you need to divide it by 3600, because that's going to get you a smaller value, right? That's like, because you can go a lot less far in a second than you could. This would be how far you could go in feet in a hour, but you have to divide it by 3600 to get how far you can go in a second. Okay. So now 87. So today Tien's age is 1/4 of Jordan's age. So Tien's age is 1/4 of Jordan's age. Now in 2 years, Tien will be T plus 2 years old, and that's going to be 1/3 of Jordan's age, right? And in 2 years, Jordan will be J plus 2 years old. So now we have a system of two equations. We want to know how old Jordan is today, so that's J years. So we're solving for J. Okay, so I'm going to plug in this expression for T into this equation. So we have T plus 2, which is 1/4 of J plus 2 is 1/3 J plus 2. Okay, so here, let me rewrite this. So that's going to be, we have 1/4 J plus 2 is equal to 1/3 J plus 2/3, right? I just distributed this out. Okay, and then you can go through the algebra to solve for this. I'm going to take some shortcuts. Let's see. So it would be D, right? Because we're solving for J. So that's how old Jordan is today. Okay, so 88, how many positive even factors of 48 are greater than 24 and less than 48? Okay, so let's actually try to factor 48. Well, actually, I mean, this is pretty straightforward, actually. So if we want to look at the factors of 48, and it must be greater than 24 and less than 48, well, anything that's greater than 24, like 25, 26, it can't be a factor of 48, because if you look at 24, 48 divided by 24, it goes into it 2 times. So anything that's greater than 24, like 25, would go into it less than 2 times, right? 25 times 2 is 50. So there aren't, 24 is sort of the greatest factor of 48, and anything bigger than it, like, won't be a factor of it, unless you get to 48, in which case, because 48 divided by 48 is 1, right? So that's the next factor. But anything sort of in between is not going to be a factor. And so if we want to know how many, like, forget even positive even, but how many factors of 48 are greater than 24 and less than 48, it's going to be 0. So sort of a trick question. Now 89, we're being asked to, like, add mixed fractions, I guess. And what I'm going to do here is I'm going to add the numbers first and the fractions later, right? So 2 1/5 is just 2 plus 1/5. And then 3 3/10 is just this. Plus 4 2/5 is 4 plus 2/5. And 5 1/2 is 5 plus 1/2. Now I'm going to add the numbers first. So 2 plus 3 plus 4 is 9, plus 5 is 14. And now let's add 1/5 and 2/5. So that's 3/5. And we have to add 3/10 and 1/2. Okay, so we need a common denominator for these. So it's going to be 14 plus 6 over 10 plus 5 over 10 plus 3 over 10. And that's going to be 14 plus 14 over 10. And this is 14 and 7 over 5, right? Just dividing 14 over 10 by 2 on both sides. And that is, oh, right, okay. So then 14 and 7 over 5, it's the same thing as 15 and 2 over 5, right? And the reason for that is because, hang on. Let me just clear up some space here. So if we look at, like, 14 and 7 over 5, this is just 14 plus 7 over 5, which is 14 plus 1, or it's 14 plus 5 over 5 plus 2 over 5. And this is going to be 14 plus 1 plus 2 over 5, which is just 15 and 2/5. So that's going to be D. Okay, and now finally we'll do 90. And then we'll end the video for this time. An unmarked straight stick will be laid end over end to measure a distance of exactly 72 feet. Same stick will be used in the same way to measure a distance of exactly 30 feet. What is the length of the longest possible stick that can be used for both measurements? Okay, so basically, if we have a stick and we're measuring 72 meters, right? So we're taking this stick and then we're moving it to, like, here, and then we're moving it to here, and then to here, and we measure 72 feet using this way, right? So basically the length of this stick, if it's x, 72 divided by x, it needs to be like a whole number an integer, because if x is not a factor of 72, then this stick cannot measure exactly 72 feet, right? It might in that case, like let's say x is a little bit longer than that, like here, then it's gonna be too long, right? And it won't be able to measure it. So x has to factor 72. X has to be a factor of 72, and x has to be a factor of 30, right? Because the same stick is being used. So we need to find basically the greatest common factor of 72 and 30, right? Because we're being asked for the length of the longest possible stick that can be used for both measurements. So given that given that the length of the stick must be a factor of both 72 and 30, we need the largest possible factor, which is going to be the greatest common factor of these two numbers. And so we're finding the GCF of 72 and 30. So let me find that. Okay, so actually we can sort of just look at the answer choices. So 8. So 8 is a factor of 72, right? But 8 is not a factor of 30, so that doesn't work. So then the next largest is going to be 6, right? So 72 divided by 6, that works. And 6 is a factor of 30 as well. So therefore 6 is a common factor of 72 and 30, and it must therefore be the largest because it's the largest answer choice that works. So that's going to be the answer. Okay, and we'll end there.